Good? You feeling good? You guys look like you're having a good time. Okay, nice. I'm Henry Gordon-Smith. I'll be moderating today's session. And we're going to be talking about circular economy and various parts of that, which is a really exciting topic. I'm from Agritecture. If you want to learn about us, our booth is just back there in the corner. But again, today we're going to be talking about the transition pathways towards circular material streams, focusing on nutrients and substrates. And we have an amazing panel, including someone from Wageningen University. That's Alexander. Hi, how you doing?
Good, yeah, how are you?
I'm good, thank you. There you go, like get the energy out.
Yeah, that's it.
Okay, we've got Head of Sustainability for Grodan here. Wow.
Yep.
That's you, right?
That's
okay, I got it. Look at the photos.
We're sitting in
We
the same
tried to
order
sit
as
in the
it is
right
photos.
order.
Oh, that's very, very organized. Okay.
It's a scientific approach.
And then we
that's
have
how we
Marc from Van Eerperen International, Director of Innovations.
That's me.
Okay, awesome. And then we have Marco over here.
Yeah, that's me. Hello.
Okay, great. Let me get comfortable. It's my last panel of the day.
All right.
So I'm just going to read the description a little bit, give you guys an idea of what we're talking about, and then we're going to get into some introductions and this topic. And if you have any questions, we'd love to hear from you if you want to understand this topic more. So what we have here is a mix of parties from substrate and fertilizer world to talk about circular economy. Who knows what circular economy is? Raise your hand. Wow. Okay, so we're going to have to define that. We're going to introduce opportunities and challenges related to driving sustainability and circularity. Is it difficult? How does it work with substrates, fertilizers? How do we make it easier? What are the innovations? And again, this is all under the objective of reducing emissions and making sure we're using as much as possible. We don't want to have sort of linear systems that go from A to Z, but create more circular systems. So let's actually start with a bit of an introduction from each of you, and then we'll talk about circularity, since they don't understand it that well. So Alexander, tell us who you are, and what is the circular economy, or what about that is interesting to you?
Sure, yeah. So I'm Alexander van Tuyll. I'm a researcher at Wageningen Greenhouse Horticulture, and I'm working on this very broad theme that we call circularity. And that's on many different material flows, CO2, water, substrates, nutrients. And it's everything from the sector in general, but also how do circular approaches affect the grower? If the grower has to use different kinds of inputs, how does that affect the day-to-day running of the business? And so circularity to me is about a more sustainable way of doing things in which we're no longer dependent on finite natural reserves, and we are also no longer polluting the environment by losing these resources and just getting rid of them. So it's about closing the circle, and it's about more than just efficiency, but it's also about making sure we're no longer dependent on things. So that's in a nutshell what I work on.
Andre, tell us more about who you are and anything to add to the circularity definition.
Yeah, I'm Andre van Wageningen, not from Wageningen University, just to make sure we're not confused here. Working for Grodan as head of sustainability. And for us, circularity means producing sort of keeping in mind nature's limitations. Yeah, so in a sustainable way of production. And of course, as Alexander also said, there's never one circular part of a process. There are always in the system many circular economies or circular systems which you all have to take into account. Well, in the end, of course, we do this to make sure that we still have a sustainable system in the future. And you all have to look at it from a sort of like an ecosystem perspective.
Great. Excited to talk about what Grodan's doing there. And let's move over to you, Marc.
Yeah, my name is Marc. I work for Van Eerperen International. I'm responsible for innovations inside Van Eerperen International. Born and raised in the synthetically derived fertilizer market. So I know this market inside out, and I also know the challenges. On top of that, I'm also a farmer in the weekends and in the evenings. So I also know how to, what challenges you have. Sugar beets, chicory, seed potatoes, grass seed. So an arable farm. So it's,
an arable farm.
It's whatever I try to come up with in the company, I also have to implement accordingly, especially my sales colleagues in the field. And only after then they will start working on it. So
you're the guinea pig. And Marco?
Yeah, my name is Marco Zevenhoven, Director Operations at RHP. RHP is a knowledge center for substrates. We have also a quality mark, so certification. as well as a research department regarding the technical specifications of substrates. I'm in the industry already for a long time. I'm a son of a grower, so the roots are, let's say, in the soil. And the substrate is, of course, not linked to the soil. For us, in RHP, circularity plays more and more a role. In the Netherlands, we signed recently a covenant with all kind of stakeholders to come to more renewable materials as a constituents of substrate, of organic substrate. And we play in this covenant a role regarding supplying of knowledge, research, and to support the industry in this pathway.
Fantastic. Wow. We have the great people here today. I think there's a slide that's going to explain circularity a little bit. Can we show that?
Yeah, we're going to start with one that talks about,
see it
well,
over
linearity, of course.
Yeah.
Can we have the first one, please?
Yeah,
the one about, I've just
The
got
question here is
There
like,
we
what's
go.
the problem with the current linear systems, right? I think that's the question we're trying to answer here.
Yeah, so what you see here is all the material flows, well, not even all of them, but we've just focused on 6 that are required to grow a tomato in a typical Dutch greenhouse. So you see at the top water, then nutrients, then CO2, and this is just the dosage to increase the indoor concentration. Then we have stone wool as a growing medium, and then we have certain kinds of plastics. And you see how much goes in on the left-hand side per kilogram of tomato. And then what we see on the right-hand side is where it all ends up. So we see how efficient greenhouses are with all of these material flows. That's the first thing we can see. But we can also see where everything ends up. So an example we always like to talk about is how plastic ends up being mixed with the leaf trimmings and stems. So if you want to apply that as a compost or perhaps something more useful, then that's always a challenge. So this sort of gives us an idea, and you also see that substrate has a few things mixed in. Another thing you see, I just want to say this is not to scale. Obviously, water is by far the biggest flow, but you do see within the flows what happens to them, and that's a good starting point. And again, I want to stress that although we're very efficient, efficiency is not circularity. These, for example, nutrients, still have to come from mines, and one day these mines will run out, no matter how efficient we are. So that's more or less an
You're really
overview.
emphasizing that independence, like
Yeah.
like some of the materials or inputs you need could be sourced more locally or within the farm itself.
Yes.
That's for you like one of the biggest benefits of circularity.
Absolutely, yeah.
What are the other problems with a linear system like this, besides that you have to import the product? Anyone can answer.
Okay.
I would say with a linear system, in the end, you always end up with discarding things that have value at some point. So it's never gonna help replenish the natural resource that we have.
Yeah, but I think also your point is like it's a little bit of like incomplete accounting. Like there's something that going out of your farm that could be worth something, but you're not accounting for it at all. It's just going away. It could be a resource. It could have an impact, but it's just sort of not accounted for. But if you think in a circular way, you start to have to account for more parts of the system.
Yeah, and of
Every
course,
part of the system.
there are many ways of circularity, whether it's reuse, recycle, or whatever. Right? So it's not a single solution as well.
Any other problems with this linear approach?
I would say that not so much with the linear approach, but I think we have to keep in mind if you talk about circularity that it is the high-tech greenhouse on soil is one big web. If you move a thread there, the entire web is moving. Yeah. So it is not so easy to find solutions for this alternatives for this linear approach. So also within Veneper International, we really focus on alternative production methods, where, for instance, purity of the product is essential. So you can come up with all kind of circular products, but if it is loaded with sodium, definitely you will have another issue, because we don't want to flush the water, and you don't want a sodium accumulation. So these are a few of the challenges that you face in order to be able to really implement in the field circular fertilizers. And on top of that, also there, it's I think also important to realize that at this moment, the grower doesn't get a big extra premium. So it's really a challenge to come with alternative fertilizers that are 4 or 5 times more expensive. So also from that perspective, also from economic point of view, in the end, you should be in compliance. There is always, if you come with a new product, a new initiative, there were always a few growers that want to be ahead of the gang. But in the end, you want to capture the gang, and that's the most important thing, because then you really can make a big difference in the circularity, and then a big difference in the improved sustainability of the tomatoes and the cucumbers.
Okay, you made a lot of points there we have to unpack, but we're going to sort of go through it through the panel. But I think, one of them is that, all the systems in greenhouses are connected. So it's really difficult to pursue circularity because the domino effect needs to be understood before you do that. Yeah. And then your last point was a little bit different. It was more about, where's the incentive to do it when you're not getting more money for the product, which I think are both good points. Yeah. So let's just continue and introduce circularity a little bit more in the next slide, right?
Yeah, I think the next slide is about stone wool. But I think we get to that in a later question. I don't know. But
okay.
I don't know what. Yeah. Anyway.
Okay, great.
Now we can share what we do. If you leave this slide, if you go back one slide, you see the stone wool going in with 6.1 grams and also 6.1 grams leaving in as a substrate. If you now go back one slide, then I can show you what we do. We make the stone wool from a natural, abundant volcanic rock being basalt. And then we first make the substrate, in which we use to grow cucumbers, sweet peppers, but also tomatoes, for instance. And then in the end, it's being recycled into bricks as a reuse for the substrate, end of life. And then you can see you go from 1 cubic meter of natural basalt to 50 cubic of stone wool, and in the end 8 cubic meters of bricks. And this is something that, of course, we don't leave our customers up to figuring out themselves. So we actually help customers across the globe to find the brick factories that are willing to use the used stone wool.
Okay, so it goes from the basalt, the sweet peppers and the cucumbers.
The sweet pepper and the cucumbers are what happens in the greenhouse.
They're options of what happens in the greenhouse, right?
They're examples of what happens in the greenhouse.
But it really goes basalt, stone wool, cucumbers, sweet peppers, and then brick after it's used, is what you're saying. Yeah. I didn't realize you guys turned it into brick. Can you tell us more about that?
It's a well-accepted solution, I think, about some of the end-of-life material go back to the factories, where we, again, turn it into stone wool as substrate. But the biggest part in Europe goes to brick factories in different countries. And you can imagine you don't want to ship a lot of bricks across Europe for various reasons, but logistics being the most important one. So we have, in most of the countries, we have a brick factory which actually accepts the stone wool as a feed to make the bricks.
Okay.
So we always say we first help to feed people and then we help to house people.
So that's cute. So this is what circularity practically looks like today with Grodan's products.
Yeah.
Okay. I mean, what percentage of your growers are actually putting that substrate to brick buyers?
Whatever we sell in Europe, about 100% or even more, because we tend to recycle also stuff that is made by our competitors, is being recycled.
100% in Europe?
Yeah.
Wow. I didn't know that. That's new information for me, which I think is very interesting.
Yep.
Okay, great. So we talked a little bit, Marc, you talked a little bit about the downsides of...
The challenges.
Challenges.
I don't like the word downside.
No. You don't like the word downsides? Okay.
No.
So does anybody want to add to those, or do you have any more to add? But what are the challenges with circularity?
I'd like to just summarize it in one way, and that is that the reason we're so efficient with fertilizer is because it's linear, because it's come from such a pure source. So as Marc said, it's very difficult to be circular whilst maintaining the efficiency that we have, that is only possible so far because of its linearity. So that's the big challenge, how I'd summarize it.
And that's what you're saying, because the quality and the purity of it is better, so it performs more efficiently. You know what you're getting. You don't need to measure and change it too much.
Yeah.
And so what does fertilizer look like in a circular greenhouse?
Yeah, well, perhaps I know Van Ieper is working on that.
So that's we have a few examples. I've decided to focus on the nitrates. So we, by far the biggest, if you look at the carbon footprint, the biggest part of the carbon footprint is from heating the greenhouse and the electricity, of course. And then on the second spot, it's the fertilizers in general and the nitrate specifically. So what we are doing at the biogas location in the east of the Netherlands, we work closely together in order to turn the ammonium, which is inside the digestate, into nitrates. So at this moment, as we speak, we produce potassium nitrate, where the N comes from the digestate of the ammonium comes from the digestate of the biogas industry. So like this, we are able to connect all the different sectors. So on one hand, you have the biogas industry, which has a big problem in order to be profitable, which is the digestate, how to valuize this digestate in a proper way. On the other hand, we have livestock farming. And some of us might have known we have something like a nitrogen issue. So there also we might have a contribution in that. And then, of course, also the horticulture, which has a challenge after they managed to tackle their CO2 emission regarding to the heating and of the greenhouse, also to come with a more sustainable nitrogen. And that is how we try to connect everything together. So I think part of the solution is not to look only into your own sector, but especially outside. Another project that we are doing, we work, for instance, with the car battery industry. That's a completely different project that we are doing. But also there, we are going to produce potassium sulfate, where part of the raw materials, the biggest part of the raw materials, will come from the car battery industry. So for me, one of the things is look outside your own sector and try to find and see what is going on there.
Yeah, I think it's really cool to think about, again, how greenhouses can work with other industries and segments. And yeah, circularity is not just on a per operation basis, but it's really looking at the country or even other places overall and how those resource streams. One man's trash is another man's treasure, right?
Clear, yeah.
Okay, cool. What other slides do we have?
I think that's the vision, but
so
I
this
think
is the
RHP has a few. Anyway.
Let's talk.
Yeah, perhaps it's good to connect it to substrates or grow media. This discussion. As said, we signed a covenant, and it means that we have to work more and more with renewable materials. But that's not easy. We have, of course, experience with bark for the orchids, the biggest pot plant in the Netherlands, for example. But we have a huge challenge to get enough volume to replace the materials which are not sustainable. And in this process, we face several risks. We see that when we go circular, that a lot of renewable materials consist of has residues of pesticides. For example, every green waste compost, 70% carries one or more pesticides. But also with bark from the wood industry, some liquids are used, but also human pathogens. In the most of substrates we use at the moment, we have no real risk with human pathogens. But we see when we start to reuse materials that we find high concentrations of Salmonella, E. coli, which can come back into the food industry. When you grow basil in a pot and you buy it in the supermarket, but in this pot there are human pathogens, then we have a serious risk. So that means that we have to invest in processing raw materials to make them safe. Several processes are known and clear, but research is necessary to take away a few other risks in renewable materials to make them available for the industry. In the Netherlands, we need for the coming years around 4 or 5 million cubic meters of renewable materials. That's a huge pile of products. And the Wageningen University is doing research to find where are these products, can we make them safe, and can we use them. And RHP plays an important role with the 71 companies who are in that production. So I think it's important when we go circular that we take in account that we have to face risks to avoid that we get huge disasters. And maybe it's good to add, we are involved in claims of growers which has problems with substrates, and that are mainly the biggest claims. And we managed in 2022 12 claims, and 6 of these claims have to do with renewable materials. So it shows that we have to gather more knowledge, that we have to take the risk away, that we need processes to take this risk away to come to safe products in the grow media industry.
And this is why standards and an organization like yours is so important, because you do this research You interface with policymakers as well and the growers. What else does your organization do to get information like this out there? And your mission is to encourage more renewable materials, but you're also like proceeding with caution, right? You're saying, how do we do this safely?
Yeah. Safety is very important, as said, and also to get clear if a renewable material is also sustainable, because that's not always one-to-one.
Right.
Yeah. When we have a renewable material, but we have to put a lot of energy in the product and water to make it safe, then we are not on the right way to go. So it's very important that we are using LCAs, life cycle analysis, that we can compare products and that we can improve, because we have to improve, we have to come to lower environmental impact for in the substrate industry.
And what's the current context of LCAs for this sector? Because I know in general in CEA, vertical farming especially, there's almost none. But is it more mature in Dutch substrates? And
there is a development in Europe which is initiated by Grow Media Europe, the association, which asked an expert group to make an LCA system. This is introduced in the beginning of this year. It's version 1, to be honest.
Right.
But step by step, we have to learn. It's based on secondary data. Next step is to come to primary data, and then to bring it as a whole in the chain, because substrate and fertilizers are just a part of the chain. And we are talking about a whole horticultural chain. At the moment, someone comes with a new substrate which is sustainable, which is circular, but the grower needs 3 times more water and 4 times more fertilizers and pesticides and whatever, then we don't reach our goal. And that means that we have to go for a chain approach. And for example, in Europe now, the FloriPEF is developed, where the whole chain approach from the beginning until the end for ornamentals is organized, and substrate and fertilizers are a part of it.
I mean, all of this makes it sound very difficult for an operator to actually pursue circularity. And I want to go back to one of the main benefits you were saying, which is sort of independence. Can you give us some examples of how it really makes you independent, or reduces your dependency on external outputs? And why does that matter, especially more in the future than today?
Yeah, very good question. Right now, a lot of inputs, I mean, we've already seen with natural gas prices skyrocketing over the last year, and that's had a huge effect on growers. So naturally, that's the thing that people are thinking about. But all of these things equally apply to other flows, whether it be substrates or fertilizers. There's such a thing as peak phosphorus, which could be as early as 2050. And after that, things are going to get more expensive, lower quality. It's going to be a lot harder to come by. So definitely economically, and also to keep the sector viable long term, we're going to have to think of circular alternatives. And so phosphorus is just one example, but it applies to all the other material flows too.
Does the government incentivize circularity in farming? And should it?
There are some goals. There's a very ambitious goal to reduce the import of primary natural materials, so minerals and oil, by 50% by 2030. I won't say whether that's realistic or not, whether we'll get there. Hopefully we will, who knows. But there is that goal, yes.
And should government, I mean, it seems like it's very difficult for growers to do this without some incentives or some support.
Yeah, I would say in general, changes are very difficult for people. So I think incentives will help. You could ask, you could question whether then sort of the carrot or the stick works best. I would be very much in favor of sort of rewarding the people that move towards circularity or that have a system for recycling. And what you sometimes see now, of course, recycling is hampered by all kinds of legislation, which makes it very difficult for people to use material, because at some point you become, instead of a producer, you become a waste recycler, which has a totally different sort of requirements from a legislative perspective. Yeah. Of course, human health should always be top of priority, but sometimes there are things which probably could be a little bit easier for people to move them towards circularity.
I fully align there, but of course, whenever you have innovation, the policy is not there yet. So the policy should follow quickly. But definitely, you have a point there. Yeah. And on the other hand, it's not only the government that is pushing it. You see it all around the world. The consumer doesn't want non-circular products anymore. The consumer doesn't want emission high food anymore. So I think the consumer will also be our guide to the future, even more than the government. And yes, of course, there is subsidies like DAY and investment subsidies that really push you in order to invest in more sustainable production processes. But it's the market which can really make the difference, I would say.
Now if I can build on that, of course, we're all consumers, so we all make this choice. And then what I would like is at least to be informed in a way that, in an easy way, without doing a PhD study, that I can know what is a sustainable choice or what's the impact of the choice that I make. Yeah. And that's, of course, something where RHP can play a role, where Wageningen University plays a role. Yeah.
And starting with a good path, as you mentioned. That's the starting point, I would say.
And clear communication, which is, I already mentioned a few times, the covenant communication to the consumer is one of the topics. To inform the consumer in the right way what is done by the industry. And as said, the retail market is also involved. For example, IKEA has a policy about substrates. They wrote a book about, a report about how they see substrates. And I think it's important to take them along or the other way around to improve the situation.
So the challenges we're facing now are just going to get more difficult in the next 10 years and beyond. But I'm curious let's start with you, Marco, what your vision is for a more circular system, especially in horticulture. What's your bold vision? What would you like to see? What do you think is possible?
When I talk about substrate, of course, that is almost full renewable materials. I hope we can reach 100% and manage the risk in a way that there are, first of all, no disasters, but that it's kept in the whole chain. And that we can offer the consumer a honest product which is grown on substrates and use fertilizers from the circular economy.
What about you, Marc?
Yeah, from my perspective, it's technology is the key word. I mean, if you talk about potassium, we are there. As of next year, early next year, we will produce together with our partners 100,000 tons of potassium sulfate in a competitive way, coming from the car battery industry. If you talk about the nitrogen, technically speaking, we are almost there. If you look at competitiveness, we still have some steps to make, but we are quite confident that we can get there. You mentioned P, for instance. P will be a big issue, not only in availability, but we have some sewage sludge, which you cannot use for landfill anymore, at least not the ashes from the incineration process. So also there, you are wondering, can we not use that? And then the easy thing is to do recycling, but the most difficult thing is to do upcycling, meaning in order to use this for a struvite or a calcium phosphate or whatever at a very low value product, the business case is very thin. But if at a certain moment of time you will be able to produce technical grade phosphoric acid from that same phosphate, which at least as far as I can see today is not yet possible, but there is 4 or 5 different parties in Europe working hard on that, then also from business case point of view, that would probably be the best situation. So for me the key word is not recycling but upcycling, and for that we need technology.
What about you, Andre?
Yeah, a lot of things have already been said, but I would say twofold. One, for looking at our own product, I would say we can even be better at lowering our footprint. For instance, when it comes to a small part of the plastics that we're using, moving to biodegradable plastics.
Right.
Looking at it a little bit from a more holistic perspective at the food system. I think ultimately it would be nice if a day overshoot day, World Overshoot Day, would not be in April, but would be 31st of December. Because that would mean we would be in balance with the natural resource that we have to produce our food.
Yeah, wouldn't that be nice?
Yeah.
And Alex, maybe you can explain this to us, what we're looking at here.
Yeah, so this is not my vision, but it's the vision of Wageningen University and Research on circular greenhouse horticulture. And what you see in grey around that circle are all the current natural resources that we depend on. And eventually we want to replace those with circular sources. Now, I don't know what those exactly are going to be. This is just an indication, of course. But I think what is key, and that you see in the top right, is that we will start making connections with other sectors. And that's what I think everyone here has mentioned at some point. And we summarize that as efficient, clean, and connected. Now, efficient we already know. Clean is about making sure that what leaves the greenhouse is able to be used by other sectors, and that brings us to connected as well. And I like the use of the word upcycling there because as greenhouses can do, as agriculture does in generally, we're able to upcycle things into fruits, vegetables, flowers, all these wonderful products. And we need to figure out what the niche of greenhouse horticulture is within that. But it starts with connecting to other sectors. And then I'm sure we'll find out much more from there on out.
A nice little graphic to explain how it could look.
Yeah.
Well, let's open up to some audience questions. Does anybody have questions about circularity? Yes, please. Do you mind coming to the front?
So you've spoken about taking things from one place to another, and I'm imagining these are quite linear flows from one company to another. What infrastructural changes at a sort of countrywide or EU-wide level would you like to see to make circularity embedded within that country or region?
Thank you.
Yeah, it's a tricky one. I mean, first of all, on what scale do you want to do that? Because you could do that on a very local level.
Let's say like the Netherlands.
yeah.
What infrastructure does the Netherlands need to get more circular?
I think talking about substrate, it will have a huge impact because the actual infrastructure is based on peat, the logistics, the transport, which has a huge impact, of course, when you talk about environmental impact. When we go more in the direction of renewable materials, I think that the transport distances will be shorter. But companies have to invest in a complete other structure. I'm sure about that. So that has also serious consequences.
So it's going to be expensive and difficult. That was the answer?
Yeah, and it takes time.
To start with.
Okay. Any other questions? Circular questions?
If I can comment on... If I can
yeah, you can go for it, yeah.
So I think it's if you look at the fertilizer industry, it's globally very centralized industry. So there's a few big players, few big producers, centrally organized in different locations. And I think also there, also if you talk about this car battery thing, it's also very centrally organized in the north of Sweden, where also happens to be paper pulp. So still there, you will keep the centrally organized thingy. That is inevitable. On the other hand, a completely different project is the nitrate project that I explained. There you have a lot of local biogas industries. So where it only was a very centrally organized industry, you now, product by product, will see a deviation in the fertilizer industry.
Yes.
Yes, thank you for your all the discussions here. You talk a lot about circularity regarding the resources in order to grow the crops. For example, the kilos of tomato and everything that's needed to grow kilos of tomato. This is a green tech event, and there's a lot of technology that's being used in order to grow. What do you think about the circular aspect of that?
Like what kind of technology specifically?
Yeah, like
should
the infrastructure of a greenhouse, all the technology, the sensors, the climate computers, everything like that.
The relationship between that technology and the goal of circularity.
Or the circular aspect of those materials as well.
Oh, of the industry.
Yeah.
Okay.
I can give an answer on that. We know that when we change to other substrate, that every substrate is asking for a certain nutrition. We get a lot of materials which are immobilized nitrogen. And that means that you have to add more nitrogen during the cultivation. We know that there are already a few companies who create a system in their greenhouse where they have a kind of trolley which is going over the crop. They have colored flags per segment, it's recognized by a computer, and every segment gets his tailor-made nutrition. So there you see a solution from technology which fits into let's say the new properties of substrates, which has an extra demand for a certain element.
Great. Any other additions to the question?
No, I think it just shows that the greenhouse has many circular systems in itself, and I think it's a little bit like think big, start small. You have to start with something, and then and I think we all have a stake in making it as circular as possible.
But the embodied energy of the equipment is an interesting comment, because like in vertical farming, it's a really huge part of the overall carbon footprint is just the embodied energy of all that equipment. So if you could make some of that more circular, it'd be appealing. But you always have to compromise, it feels like, with circularity. Like human health is a compromise, quality, consistency. It's difficult.
Yeah, it is. I'm afraid I haven't got
He's like,
any
that's why I
better
like
news
it.
than that.
He's like, I like it because it's hard.
Lots of projects. Yeah, no, it is difficult. That's the thing. Yeah.
One last question.
Anyone?
Do you think there's a sector where circularity is much easier? Like, is horticulture like on the more difficult end, or?
I think each sector will have its own challenges, and I think also if you talk about circularity, like the word upcycling I mentioned, but the limiting factor is always what is left.
Yeah.
What is left after you upcycled something? Still there is something left.
It never ends, right?
It never ends, and that is, I think, whatever sector you are, it's in order to be able to get a good business case. The product that is left after you did whatever you did probably determines also how strong your business case is, and that is, I think it's all over the different sectors. It's the same thingy.
Great, thank you. Well, let's have a round of applause in a circle for our amazing panelists. Thank you so much for your time, gentlemen. Really appreciate it.
Thank you.
You're welcome.